Hello, I'm Paul Foster. I've been around safety training for more than 30 years now. I started out as an engineer on building sites, and I saw with my own eyes just how dangerous confined spaces can be. One close call nearly ended in disaster, and that moment made me realise how vital proper safety rules really are. I've got teaching qualifications, QTLS, Qualified Teacher Learning and Skills, a NEBOSH diploma, and IOSH certification. Over the years, I've worked on big jobs in petrochemicals, rail, and construction, and I've trained people across the world to keep themselves safe in risky places. This course is called Confined Space Safety Essentials for Construction. Master the Diligent Safe System. Don't worry if regulations feel complicated or if budgets are tight. The aim here is to give you clear, practical tools so you can handle confined space safety with confidence. The SAFE system is something I've built up from years of experience and lessons learned the hard way. It's a simple, proven way to make safety management work in real life, not just on paper. In this course, we'll cover what confined spaces are, why they're dangerous, and how to put the SAFE system into practice. By the end, you'll feel ready to protect your team and meet the rules without fuss. So within half an hour, you should have everything you need to understand to keep your workers safe. In order to keep them safe, you will definitely need some more training. But it's a start, and you don't gain anything if you never start.
Now it's your turn.
If you faced a situation where your knowledge is limited, what would you do? Here's the best response. Right then, so let's get started, because safety should always come first.
Lesson 2. Why confined space safety matters. Confined spaces and the diligent SAFE system. A confined space is any place that's enclosed or mostly enclosed where there's a real risk to workers. That risk could be fire, explosion, passing out, suffocation, or even drowning. It might be something small and tight where you can hardly move, or it could be much bigger, like a storm drain that could hold hundreds of cubic meters of water. The danger comes from things like nasty fumes, not enough oxygen, or the chance of fire. Other risks include flooding, drowning, or being suffocated by dust, grain, or other materials. The diligent SAFE system. This system is a straightforward way to manage one of the most dangerous parts of construction work. It's built on 4 pillars, each one adding to the next, so you've got a solid framework for safety. S. Site assessment and hazard identification. First job is to spot confined spaces, check the hazards and write down the risks before anyone goes in. If you don't understand the environment, you can't prevent accidents. A. Access control and permits. Only trained and authorized people should go in, and only with the right permits and procedures. This is the gatekeeper, so it keeps things controlled. F. Full PPE and equipment training. Workers need the right protective kit and must know how to use it. PPE and breathing gear are the last line of defense if something goes wrong. E. Emergency response and rescue. Have a rescue plan ready, train your team, and make sure evacuation can be done quickly. If trouble comes, you need to act fast and effectively. So, why it matters? Around 60% of deaths happen because hazards weren't spotted at the start. That shows how vital proper assessments are. Rescuers often become victims themselves when there's no proper emergency plan. That's why a clear exit strategy is non-negotiable. The law is clear. Under the Confined Spaces Regulations 1997, you can face fines or prosecution if you don't comply. Most accidents in confined spaces can be prevented with good planning. This course is here to give you the know-how to stop tragedies before they happen. The diligent SAFE system is your blueprint for keeping people safe. By putting it into practice, you'll not only meet the rules, but also protect the most valuable thing you've got, your people. Right then, let's crack on and make safety the priority. Lesson 3. S. Site assessment and hazard identification. Why site assessment matters. Site assessment forms the foundation of all confined space safety. Without proper identification and hazard evaluation, workers enter blind. unaware of atmospheric dangers, structural instabilities, or hidden mechanical hazards that could prove fatal within minutes. Statistics demonstrate that most confined space fatalities occur because hazards were not properly identified or communicated before entry. A thorough site assessment doesn't just tick compliance boxes. It creates the knowledge base that informs every subsequent safety decision. This module equips you with the systematic approach needed to assess any confined space confidently, ensuring that nothing is overlooked and every risk is documented, controlled, and communicated effectively. What is a confined space? A confined space is any area that is substantially enclosed and presents a risk due to limited access, poor ventilation, or hazardous substances. Understanding this definition is the first step in protecting workers. The Health and Safety Executive, HSE, is the UK's national independent regulator for workplace health, safety and welfare. Its primary role is to protect people from harm by regulating and enforcing health and safety laws, as well as providing guidance and support to employers and employees. The HSE also conducts research into occupational risks and promotes best practices in health and safety across various industries. The HSE definition of a confined space is any place, including chambers, tanks, vats, silos, pits, trenches, pipes, sewers, flues, wells, or similar spaces where, owing to its enclosed nature, there arises a reasonably foreseeable specified risk to workers of fire, explosion, loss of consciousness, asphyxiation, or drowning. What is substantially enclosed? The space is largely closed off, limiting natural ventilation and creating conditions where hazardous atmospheres can develop or persist. This doesn't require complete enclosure. Partial barriers can still create confined space conditions. What is limited access egress? Entry and exit points are restricted, making rapid evacuation difficult. This could mean small openings, vertical access requiring ladders, or locations that would impede rescue operations during an emergency. What do we mean by not designed for continuous occupancy? The space is not intended as a regular workplace. This means it may lack proper lighting, ventilation, temperature control, or other features that make conventional workspaces safe for extended periods. Here are some common confined spaces in construction: tanks and vessels, storage tanks, process vessels, and silos used for liquids, gases, or bulk materials, often contain residual chemicals or oxygen-deficient atmospheres. Tunnels and shafts, underground passages, utility tunnels, and vertical shafts present risks from poor ventilation, ground instability, and flooding potential. Trenches and excavations, trenches deeper than 1.2 meters, particularly those with vertical walls. Hazards include cave-ins, oxygen deficiency, and water ingress. Crawl spaces, underfloor areas, roof spaces, and interstitial voids often contain utilities, poor lighting, and restricted movement space. The purpose and importance of site walkthroughs. The walkthrough achieves multiple objectives simultaneously: identifying which spaces are confined spaces, noting hazards present in each space, looking at existing controls, and seeing what additional controls are needed, and establishing baseline documentation for future reference. This isn't a quick tour. A proper walkthrough is methodical, documented, and collaborative, involving personnel with different expertise to ensure nothing is overlooked. The walkthrough creates the foundation for all subsequent confined space operations at the site. Using a systematic approach. Just looking with your eyes isn't enough. You need proper checks, gas detectors for oxygen, flammable gases, and toxic vapors. You also need to think about things like flooding, collapse, or hidden energy sources. Always plan for the worst, the best, and the most likely outcomes. That way you're ready for whatever comes. Meeting documentation and compliance requirements. If it's not written down, it doesn't count. You've got to record site-specific risks, test results, and the measures you're putting in place. This isn't just paperwork. It's proof you've done your duty, and it helps you improve over time. We need a change in mindset. Safety has to come before speed or convenience. That means changing the culture, so people don't just dive in because it's quicker. It's about learning from mistakes and making sure they don't happen again. Why do we need training and awareness? Workers need to know when entry is truly necessary and when it can be avoided. Training should cover the law, the importance of risk assessments, and the consequences of getting it wrong. The aim is to give people the confidence to make the right call and build a culture where safety comes first. Go in only if you have to. The very first rule with confined spaces is simple. Don't go in unless you really have to. This isn't just ticking a box. It's about keeping people alive and safe. The law backs this up. Under the Confined Spaces Regulations 1997, employers must do a proper risk assessment before any work starts. That means looking at the risks, deciding if the job can be done without going inside, and if not, setting out the hazards and the controls needed to keep workers safe. And a final word. Put all this together and you've got the beginnings of a confined space safety program that does more than tick boxes. It keeps your team safe, meets the legal requirements, and makes sure jobs are done properly. This course is an awareness course. Further training is required to really gain understanding, get down to the requirements, and understand these systems. At the end of the day, it's about protecting people, and that's what matters most. Lesson 4A, Access Control and Permit Systems. What do we mean by access control and permit systems? Access control is the gatekeeper of confined space safety. This module covers the systems and procedures that ensure only authorized competent personnel enter confined spaces under controlled conditions. You'll learn to implement a robust permit-to-work systems, assign roles effectively, execute enhanced tracking and compliance. Access control stops workers going into confined spaces when it's not safe. Just because a confined space is safe one day, it does not mean it will always be safe. It's not just about following the rules. It's about creating a controlled entry where safety comes first. Key steps in access control. Why permits matter. Permits aren't just paperwork. They're live safety documents. The permit should only be issued after the site survey, covered in the previous lesson, has been completed, and as soon as possible after the survey. Conditions can change. If conditions change, the permit must be cancelled and reissued before anyone goes in or back in. The legal requirements. By law, under the Confined Spaces Regulations 1997, you must have a safe system of work in place. A permit to work forms an integral part of a safe system of work. It's there to make sure all precautions are taken to protect workers. Permit to work systems are the cornerstone of confined space safety. They ensure that every entry is authorized, hazards are documented, and control measures are in place before work begins. A well-designed permit system creates accountability, provides a clear communication tool, and serves as a legal record of due diligence. Permit-to-work systems are the cornerstone of confined space safety. They ensure that every entry is authorized, hazards are documented, and control measures are in place before work begins. A well-designed permit system creates accountability, provides a clear communication tool, and serves as a legal record of due diligence. Confined space permits serve multiple critical functions. They document hazard assessments, specify required precautions, authorize entry for specific individuals, and time frames. The structure must be logical, and comprehensive, guiding users through a systematic process that ensures nothing is overlooked. Before anyone goes in, there must be a permit. That includes other permits too, like isolating energy sources. This shows hazards have been checked and controls are in place. A permit should contain location information, precise identification of the confined space, including location on site, specific identifier, and access point descriptions. Include a simple sketch if the space is complex or has multiple entry points. A permit should contain identified hazards, complete documentation of all identified hazards from your site assessment, list atmospheric readings, physical hazards, potential chemical exposures, and any conditions that could change during the work. A permit should contain additional critical information, authorized personnel, complete list of authorized entrants, attendants, and supervisors with qualification verification. Include maximum number of simultaneous entrants permitted. Approval signatures, required signatures from competent person conducting assessment, entry supervisor, and site safety manager, confirming all requirements are met, the validity period, specific start and end times for permit validity. Permits typically expire at shift end or when conditions change, whichever comes first. Required pre-entry checks, checklist confirming, atmospheric testing, equipment inspection, communication systems, and emergency provisions are in place before entry authorization. The entry supervisor oversees the entire operation, ensures all precautions are in place, authorizes entry, and can terminate entry if conditions become unsafe. They must be present during entry operations. Required supervisor qualifications, all the attendant requirements plus hazard assessment competency, permit system management, rescue coordination, and have a minimum 2 years relevant experience. The attendant remains outside to monitor entrance. The attendant must maintain accurate entry logs and head counts, as these are essential for accountability and emergency response. The attendant maintains communication and initiates rescue if needed. The attendant never leaves their post whilst entrants are inside. Time tracking is performed by the attendant. It serves multiple purposes, ensuring workers don't exceed safe working durations in challenging environments, providing data for permit revalidation decisions, and creating an audit trail for compliance verification. The role of the attendant is vital. Their job is to keep a log of who goes in and out, watch conditions, and keep an eye on the workers inside, if possible, without entry. Call for rescue if needed, using the emergency plan and proper communication tools. Required attendant qualifications, all entrant requirements plus communication systems training, emergency recognition and response, non-entry rescue procedures, understanding of atmospheric hazards. The entrant, a worker authorized to enter the confined space, must be trained in hazard recognition, equipment uses, and emergency procedures, responsible for continuous self-monitoring and immediate exit if conditions change. Entrant qualifications, completed confined space awareness training, role-specific task training, PPE and equipment competency, emergency response procedures, medical fitness certification, the rescuer, specially trained in confined space rescue techniques and equipment, on standby during entry operations with appropriate retrieval equipment, ready for immediate deployment if needed. Rescuer qualifications, advanced confined space rescue training, technical rope rescue certification, first aid and CPR current, SCBA qualification where required, regular practical rescue drills, Confirm isolation and ventilation. Make sure all energy sources are switched off and locked out, and that ventilation is set up properly. This prevents accidents and keeps the air safe. Continuous monitoring. Testing the air before entry isn't enough. You need to keep checking while the job is going on. Use gas detectors to monitor oxygen, flammable gases, and toxic vapors in real time. If conditions change, get everyone out straight away and reassess. A final word. It must be pointed out that if the confined space is not safe, it must be made as safe as possible. To meet this requirement, ventilation systems, such as air blowers and extractors, must be put in place, and all energy sources must be isolated and locked in that state. This is known as LOTO, lockout, tag out. Any source of input to the confined space should also be isolated. This includes pipework and feed systems like conveyors. Atmosphere testing is also a specialist area. These subjects are covered in future more in-depth courses. Put all this together and you've got a strong system that keeps your team safe and shows you take safety seriously. Safety isn't just a priority, it's a value that should run through everything you do. Right then, let's crack on and make sure confined space work is done safely and properly. The third pillar in the diligent safety system, full PPE and equipment essentials. The difference between safety and injury. In confined space environments, proper personal protective equipment represents the critical barrier between workers and serious harm. The unique hazards present limited oxygen, toxic atmospheres, engulfment risks, and restricted egress demand specialized protection that standard PPE cannot provide. Understanding which equipment to use, when to use it, and how to use it correctly transforms PPE from merely required kit into life-saving technology. PPE is your last line of defense, so it's got to be right and fit for purpose. It's about making sure people are safe in the most practical way possible, in the hierarchy of control, elimination, substitution, engineering controls, administration controls, and PPE. The first group before PPE are referred to as collective controls, making a safe place. PPE is at the bottom of the list, referred to as safe person. This doesn't mean that it is any less important. It just means that should there be any failure in the collective methods, hopefully the PPE will keep the person safe for a limited time. Types of PPE for confined spaces. Respiratory protective equipment, RPE. Breathing gear is vital when the atmosphere might be dangerous. The kit must match the hazard and fit the person properly. That could mean a simple mask, a half mask, or a full face mask, depending on the job. The law says RPE must be suitable and fit correctly. It's not enough to just have it. It must work in the conditions you're in. Air purifying respirators, APRs, filter contaminants from ambient air using cartridges specific to hazard type. Only suitable when oxygen levels exceed 19.5% and contaminant concentrations remain below ideal H, immediately dangerous to life or health levels. Available as half-face or full-face configurations with various filter combinations. APR is suitable when oxygen exceeds 19.5%, known contaminants. The correct filter cartridge is available. The atmosphere is below IDLH levels. Self-contained breathing apparatus, SCBA, SCUBA, provides complete respiratory independence with supplied air, essential for IDLH atmospheres, oxygen deficient spaces below 19.5%, or unknown atmospheric conditions, offers 30 to 60 minutes of breathing air, depending on cylinder size and work rate. SCUBA is required when oxygen levels are below 19.5%, IDLH atmosphere present, unknown contaminants, high contaminant concentrations, or potential flash fire risk. For the full face respirator, the eyes are protected by the mask. For other half mask respirators, there is no eye protection, so safety glasses must be worn. In this case, it is advisable to use clear safety glasses, not darkened safety glasses, due to lower lighting levels in the confined space. Harnesses and fall arrest systems. Falls are a big risk in confined spaces. Harnesses, fall arrest systems, and tripods for vertical entry are essential. They must work with other PPE and be fixed to a solid anchor point. The aim is to stop a fall or keep someone safe until help arrives, or to assist in extraction of the entrant. Full body harnesses distribute fall arrest forces across shoulders, chest, and thighs. They must include dorsal D-ring for fall arrest and front side D-rings for positioning and retrieval. Ensure proper sizing and adjustment for each worker. Self-retracting lifelines. They automatically adjust slack and arrest falls within centimeters. Preferable to shock-absorbing lanyards in confined spaces due to reduced clearance requirements. They must be properly anchored and rated for intended loads. Retrieval systems. These will be covered in the next lesson, but they require the entrant to be wearing a full body harness. Typically tripods or davit arms enable rapid vertical extraction. They include winches with 3-to-1 or 5-to-1 mechanical advantage and must be rated for worker weight plus equipment. They are essential for non-entry rescue. Protective clothing, gloves and helmets. These protect against knocks, scrapes, and other physical hazards. They must be kept in good condition, repaired or replaced when needed. Skin contact with hazardous substances, extreme temperatures, or abrasive surfaces requires specialized protective clothing. Selection depends on specific hazards identified during site assessment, including exposure duration and the required dexterity for tasks. Before entry, inspect PPE for damage. Check everything before use. Wear and tear. Harness fittings. Damaged kit can't be trusted. Check expiry dates on filters. They don't last forever. Using an expired one is dangerous. Fit harnesses properly. A harness only works if it's fitted correctly. That takes training and practice. Equipment usage and safety. Understanding equipment is insufficient. Training in mastering proper usage techniques ensures PPE performs as designed when needed most. PPE only works if people know how to use it. Training and regular checks are non-negotiable. Everyone must understand their role and responsibilities. Donning procedures, respiratory protection. Face fit tests should be performed for each entrant. Improper donning compromises protection regardless of equipment quality. Following systematic procedures ensures proper fit and seal every time. Each respirator type requires specific steps performed in correct sequence. Generally, inspect facepiece for damage, cracks, or deformation. Check cartridges, correct type, not expired, seals intact. Remove any facial hair in seal area. Donning procedures, fall protection. Prior to donning, examine all webbing for cuts, abrasion, UV damage, or chemical exposure. Check stitching at stress points. Inspect buckles and D-rings for distortion or excessive wear. Remove from service if any defects found. Harness fit. Directly affects fall arrest forces and injury potential. Improperly fitted harnesses cause serious injury even when arresting non-fatal falls. Take time to adjust properly. Your life depends on it. Statutory inspections. Inspections aren't just paperwork. They're the law. Lifting gear and PPE must be checked regularly, at least every 6 months, by a competent person with records kept. That way you know the kit is safe to use. Legal requirements. The law is clear. Employers must provide suitable PPE, keep it maintained, and train people to use it. This isn't just about compliance, it's about protecting lives. Final word, get PPE right and you've got a strong safety program. It keeps your team safe, meets the law, and makes your operations run better. Safety isn't just a priority, it's a value that should run through everything you do. Better safe than sorry. Let's make sure we're getting this right. Up next, the fourth pillar in the diligent SAFE system, E, emergency response and rescue protocols.
Well, welcome back, everyone. This is the final pillar of our training, and it's one of the most critical. When you're working in confined spaces and something goes wrong, you don't have time to waste. Every second matters. This session is about making sure you know exactly what to do when the worst happens.
Why this matters? This module is for supervisors, safety officers, and trainers, anyone responsible for keeping people safe. You'll learn the requirements to coordinate rescues, carry out evacuations, and put systems in place that protect your team in the toughest situations. Even with the best planning, things can still go wrong. That's why your rescue plan must be ready before anyone enters a confined space. This isn't about paperwork, it's about saving lives. Here's the reality. Around 15 people die every year in the UK in confined spaces, and many of those deaths involve rescuers who went in without the right training or equipment. Statistically, 2 rescuers die for every casualty. That's why this matters. The legal framework. The law is clear. Under the Confined Spaces Regulations 1997, Regulation 5, you must have suitable and sufficient emergency arrangements in place before entry, and ready to activate immediately if an incident occurs. The Health and Safety at Work Act 1974 and the Management of Health and Safety at Work Regulations 1999 require employers to carry out proper risk assessments, including emergencies, implement safe systems of work, provide training, and supply appropriate equipment. This isn't optional, it's the law. Risk assessment and rescue planning. Here's what you need to do. As we learnt in the site assessment and hazard identification lesson, identify hazards. Things like toxic atmospheres, engulfment, fire, structural collapse, medical emergencies. Tailor your rescue plan. Every space is different. Include dimensions, access routes, anchor points, and atmospheric conditions. Diagrams help. Make sure rescue procedures are documented in your risk assessments, method statements, and permits to work. Remember, if it's not documented, it never happened. Rescue team and equipment. Your rescue team must be competent, physically fit, and trained in all rescue techniques. Include specialists for entry and extraction, communications, and first aid. Plans must minimize risk to rescuers. Remember, rescuer fatalities are common. Essential equipment includes tripods, winches, harnesses, stretchers, breathing apparatus, intrinsically safe communication devices, gas monitors, first aid kits, fire extinguishers. And don't forget, inspect and maintain everything regularly, with records kept. Communication and activation. What's the most important thing in a rescue? Communication. Use radios, rope signals, hand signals, whatever works for your site. And when an emergency happens, activate the rescue plan immediately. Do not wait for emergency services. If you're using external rescue teams, make sure they know your site and hazards beforehand and confirm their availability. Training and drills. All rescue team members must be trained in rescue techniques, equipment use, communication, casualty handling, and resuscitation. Conduct regular, realistic drills to test timing, coordination, and equipment reliability. And keep rescuers fit and ready for immediate deployment. Casualty extraction techniques. Vertical lift, used for spaces accessed through top openings. Casualty is secured in a full-body harness or rescue basket, then lifted using a mechanical advantage system or powered winch. requires proper anchor points and rated rescue equipment. Horizontal extraction, appropriate for side entry spaces or tunnels. Casualty is positioned on a rigid stretcher or rescue board, then moved using rope systems or manual carry techniques. Protect casualty's head and maintain spinal alignment during movement. Emergency drag, rapid technique for immediate danger situations where equipment setup time is unavailable. Grasp casualty under arms and drag backwards towards exit. Only used when speed is critical and risk of spinal injury is outweighed by immediate environmental threats. Documentation and review. Written rescue plan. Must be documented, dated, signed, and include purpose, scope, hazards, roles, procedures, equipment list, communication methods, and diagrams. Review and regularly update plan based on drill outcomes, incidents, changes in processes or equipment. Post-incident, conduct investigation and review rescue plan. Implement corrective actions. Assigning roles. In an emergency, everyone must know their role. Entrant, the person inside the confined space who may need rescue, if possible, should always try to self-rescue. Attendant, stays outside, calls for help, monitors conditions, never enters during a rescue. Rescue team leader, coordinates the rescue, makes decisions, communicates with emergency services. Rescue team entrant, goes in, properly trained and equipped. Rescue equipment and practice drills. Rescue kit must be on site, ready and in good condition. Practice drills are essential. They turn theory into action and reveal weaknesses before a real emergency. Practice drills are vital. They turn theory into action and show up problems with communication or coordination. If an emergency happens, your team should already know exactly what to do. Plan components. A good plan includes communication methods, radios, hand signals, emergency codes. Evacuation routes, clear, documented, and rehearsed. First aid, trained personnel and supplies ready. Communication is the backbone of any rescue. Without it, the plan fails. Self-rescue and evacuation triggers. The self-rescue should always be the first option if possible. Evacuation triggers must be clear and acted on immediately, no delay. Triggers include gas alarms, structural problems, medical emergencies, or loss of communication. Training and drills ensure everyone knows these triggers and responds without hesitation. Final word. Emergency readiness isn't optional. It saves lives. Get this right and you'll meet legal requirements. Go, protect your team, and keep operations safe. Safety isn't just a priority, it's a core value. Better safe than sorry. Next, Module 3, putting it all together. Lesson 7, common mistakes and real-world case study. Lesson 8, compliance checklist and quick wins. Lesson 7, common mistakes and real-world case study. Common mistakes. Even with rules and training, accidents in confined spaces still happen. The sad truth is, most of them could have been prevented. Here are the mistakes we see time and again. Skipping atmospheric testing because it looks safe. Thinking natural ventilation will be enough. Going in without a permit or proper PPE. Trying to rescue someone without the right kit or training. Real-world case study. Crane compartment. A fault was found in a crane's hydraulics, so 2 men went into a closed compartment to check it. Within a minute, one had collapsed, and the other felt lightheaded, but managed to get out. 2 more men went in to try and save the person still inside the crane compartment, but both were overcome. Emergency services pulled all 3 out, but sadly, 2 of them died. How it could have been avoided. Water had got into the compartment, causing rust. That rust used up the oxygen. If the oxygen levels had been tested, the space could have been ventilated and those lives saved. What went wrong? No one identified it as a confined space. No testing was done. No continuous monitoring. No rescue plan. No PPE. Lesson learned. Not all hazards can be seen. A quick look isn't enough. Always test, plan and prepare before anyone goes in. Better safe than sorry. Creating safe training environments. While simulations should be challenging, they must never be dangerous. establish clear safety boundaries, assign dedicated safety monitors, and maintain the ability to stop drills immediately if actual hazards develop. Use simulated confined spaces for training rather than actual operational spaces when possible. Purpose-built training facilities or mock-ups provide controlled environments without production pressures or real hazards. A simulation's response time. How quickly did the team recognize the emergency, initiate response and complete extraction? Time from alarm to first response action. Time to establish communication. Time to complete casualty extraction. Total incident duration. Communication clarity. Was information exchanged accurately, efficiently, and without confusion? Clear, concise radio transmissions. Proper acknowledgement of messages. Effective use of backup communication. Coordination between team members. Procedural accuracy. Did the team follow established procedures and use equipment correctly? Adherence to documented SOPs. Proper equipment operation. Correct sequencing of actions. Appropriate safety precautions. Decision making. Were appropriate choices made based on available information and conditions? Accurate situation assessment. Logical priority setting. Adaptive responses to complications. Appropriate resource allocation. In the next lesson, Lesson 8, we will look at compliance checklist and quick wins. You've learned the essentials of confined space safety using the Diligent Safe System TM. Now let's summarize what you need to do immediately to stay compliant and protect your team. Capstone activity. Design your simulation. Demonstrate your mastery. In this culminating assignment, you'll design a complete emergency simulation plan tailored to your specific worksite and team capabilities. Your plan should include clear objectives tied to identified training needs, detailed scenario with timeline and complications, role assignments and responsibilities, required equipment and props list, safety protocols and boundaries, evaluation criteria and scoring methods, debrief structure and documentation plan. Present your plan to demonstrate your ability to translate emergency response theory into practical training that will prepare your team for real-world incidents. Lesson 8, Compliance Checklist and Quick Wins. You've learned the essentials of confined space safety using the Diligent Safe System TM. Now let's summarize what you need to do immediately to stay compliant and protect your team. Here's your quick compliance checklist. If you have not already done so, complete the following. Site assessment. Identify confined spaces and document hazards. Complete the workbook for Lesson 3. S. Site assessment and hazard identification. Access control. Implement permit to work systems and control hazards. Complete the workbook for Lesson 4. A. Access control and permit systems. Full PPE. Ensure correct selection, inspection and training. Complete the workbook for Lesson 5F. Full PPE and equipment essentials. Emergency response. Have a rescue plan ready before entry. Complete the workbook for Lesson 6E. Emergency response and rescue basics. Quick wins you can implement today. Check our Confined Spaces self-assessment tool for construction environments. Download and use the provided Diligent Confined Space check sheet. What's inside and why? The check sheet is structured to align with the Confined Spaces Regulations 1997. Notably, the legal tests around necessity of entry and safe systems of work, Regs 4 to 5, and the requirement for suitable and sufficient emergency arrangements, Reg 5. It also incorporates practical elements and sequencing from the Confined Spaces Code of Practice, Safe Work Australia 2020, for example, atmospheric testing routines, entry permits, and isolation methods, adapted to UK terminology, e.g. WLs. Schedule Toolbox talks to reinforce confined space safety with your team. Check your PPE inventory and replace expired or damaged items. Check your emergency rescue equipment. Have you got everything you may need and is it inspected and certified fit for use? Remember, compliance isn't just about avoiding fines, it's about saving lives. Certification and continuous learning. Congratulations. You've completed the Confined Space Safety Essentials course. Here's what happens next. Complete the short quiz to demonstrate your understanding. Score 80% or higher to receive your certificate of completion. Download your certificate and share it with your employer or HR team. You are about to take the Confined Space Safety Essentials Multiple Choice Assessment. This test will evaluate your understanding of the diligent SAFE system principles, covered in Lessons 1-7. Key details. Format: 60 multiple choice questions. Passing grade: 80%. Time limit: 90 minutes. Attempts: 3 attempts permitted. What happens if you don't pass? If your score is below 80%, you'll need to review the course material and retry the assessment after further study. This ensures you fully understand the critical safety concepts before moving forward. Continue your learning journey. Once you pass, you'll unlock access to advanced courses designed to deepen your expertise in each of the 4 pillars of the diligent SAFE system. Site assessment and hazard identification. Confined space identification methods and risk profiling. Detailed hazard identification and risk matrix application. Atmospheric testing protocols and gas behavior analysis. Access control and permits. Permit to work systems, design and digital integration. Isolation of energy sources and lockout, tagout, LOTOTO, mastery. Role-based access control and compliance auditing. Full PPE and equipment training. Types of PPE and RPE, selection, face fit testing and compatibility. Full protection systems and retrieval equipment essentials. Inspection, maintenance and legal compliance for PPE. Emergency response and rescue. Confined space rescue methods, non-entry and entry techniques. Emergency communication protocols and drill planning. Rescue equipment, staging and integration with emergency services. Why take these advanced courses? Gain practical, site-ready skills beyond awareness. Meet legal compliance under Confined Spaces Regulations 1997. Build confidence to lead safe confined space operations. Next steps. Prepare for your assessment, aim for 80% or higher, and then explore advanced modules to become a true expert in confined space safety. Stay safe, stay vigilant, save lives.